Making technologically advanced products that are affordable and available at scale is required to build a flourishing and unconstrained society. Elon Musk made the mission crystal clear in Tesla's master plan for build a truly affordable EV that lasts. With that lens, the rumored under $9,789 Tesla Model 2 gets a reality check. Under the garage lights, we're asking the real questions. What pricing logic makes this a true game changer? Which 2026 launch signals can we actually trust? And what must a budget EV deliver to survive the years of daily use, from range to charging to durability? Just what counts here? Before we dive deeper, join the autogearshift crew and help us hit 13,123 subscribers. If you love being early, the kind of person who knows the story before it becomes the headline, then hit subscribe and ring the bell. Your front row seat to Tesla's next chapter starts now. 1. How will the Model 2 be better suited for daily use than other Tesla models? Design and size focused on everyday use. Tesla Model 2 will be a 5-seat crossover that is smaller than Model Y to reduce material cost, assembly time, and make city driving easier. Expect overall length in the 175 to 180 inch range and width about 72 to 74 inches, which trims bulk while keeping a stable footprint. A tighter turning circle, targeted under 36 feet, helps with narrow streets and parking garages. Ride height will sit around 6.5 to 7.0 inches, so adults step in and out without crouching. Rear doors will open to roughly 65 to 70 degrees, which speeds up child seat installation. The second row will aim for about 36 to 38 inches of leg room, so 2 adults can ride comfortably for longer trips. Cargo space will emphasize flexibility, with rear seats that fold nearly flat to unlock roughly 45 to 50 cubic feet for weekend shopping or sports gear. Interior surfaces will use durable coatings with high abrasion resistance and stain repellents, so the cabin keeps a fresh look after years of use. The key idea is right sizing. Trim several inches of exterior bulk, and you reduce curb weight and cost, yet you still preserve the daily utility a small family actually needs. Minimalist to be affordable and durable, fewer variants and fewer unnecessary parts. Tesla Model 2 will follow a minimalist build plan with fewer trims, fewer options, fewer joints, and streamlined software. Cutting part count by even 10 to 20% has 2 direct effects. First, it removes potential failure points that create nuisance faults. Second, it shortens assembly and logistics, which lowers cost. The auxiliary electrical system moves from 12 volts to 48 volts. For the same 600 watt load, current falls from 50 amperes at 12 volts to 12.5 amperes at 48 volts. Since resistive loss is proportional to current squared, I squared R loss drops by a factor of 16. Wiring can be thinner, harness weight can fall by several kilograms, and copper content can drop by 3 to 4 kilograms. The latest inverter design reduces silicon carbide usage by up to 75% while maintaining efficiency. A permanent magnet motor without rare earths cuts exposure to commodity price spikes and keeps torque density high. These are practical engineering levers. You simplify the bill of materials, lighten the harness, and stabilize the supply chain. The result is lower cost, easier serviceability, and durability that shows up as fewer trips to a workshop over years of ownership. Seats made by Tesla with practical benefits you feel every day. Tesla Model 2 will use in-house seat production located close to final assembly. Building seats internally allows tighter control of tolerance at the seat-to-floor interface to within fractions of a millimeter, which prevents squeaks and improves crash anchor alignment. Ergonomics can be tuned directly to the body structure, with travel of roughly 250 millimeters, height adjustment around 40 millimeters, and backrest angles that cover daily commuting and long trip comfort. A typical front seat weighs 14 to 18 kilograms, so optimizing the frame and rails can remove 1 to 2 kilograms per seat and improve efficiency. With production on site, foam density, upholstery weave, and seam design can be updated in short cycles. Durability targets include more than 100,000 sit and slide cycles, abrasion resistance above 50,000 rubs on high contact panels, and low compression set so the cushion does not collapse after years of use. Integrating airbags, heaters, and weight sensors at the source also simplifies quality checks and speed service because entire seat modules can be swapped in minutes. The net effect is comfort that stays consistent, fewer rattles, and quicker repairs, which suits owners who plan to keep the car for a long time. 2. What technologies will Model 2 use to make itself cheaper, tougher, and easier to live with? Permanent magnet motor without rare earths. A new permanent magnet motor that eliminates rare earth materials will be used in Model 2 to cut supply risk and material cost while keeping high efficiency. The design combines an optimized magnetic circuit with hairpin windings that raise copper fill factor from roughly 40 to 45% into the 60 to 70% range. That lowers winding resistance and heat at a given torque. Peak efficiency targets remain above 97%, and average efficiency in stop-and-go use can improve by 1 to 2 percentage points by trimming losses at medium load. Mechanically, lightening the rotor and stator by a few kilograms reduces rotational inertia, which smooths low-speed creep and sharpens tip in response. Avoiding neodymium and dysprosium stabilizes motor cost against commodity swings. Model 2 will integrate motor, single-speed gearbox, and inverter into a compact drive unit aligned with the axle. Shorter shafts and fewer oil seals reduce leak risk and cut noise over years of use. The package is smaller, lighter, and easier to service, which supports a lower bill of materials and better durability, cutting about 75% of silicon carbide in the inverter. Model 2 will significantly reduce silicon carbide device count in the inverter while holding system efficiency. The strategy blends several steps. First, tuning DC bus voltage and control timing shortens switching intervals, so fewer devices can do the same work. Second, using highly integrated power modules lowers stray inductance, which reduces overshoot and switching loss. Third, improved liquid cooling keeps junction temperatures in a stable band, which extends device life. If a previous design needed N-Si-C MOSFETs per phase, Model 2 targets roughly 1/4 to 1/3 of that count. The result is a cost reduction on the order of hundreds of dollars per car, a mass drop of about 1 to 2 kilograms, and fewer solder joints that fatigue under thermal cycling. Control software will keep switching frequency in the 10 to 20 kHz sweet spot and will harvest regenerative braking more effectively. In mixed city driving, the efficiency gained from cleaner switching and better regen typically lands in the low single-digit percentage range. Drivers experience the same punch on throttle with slightly longer real-world range and lower inverter thermal stress over time. Do 48-volt auxiliaries, a rare earth-free PM motor, and roughly 75% less SiC in the inverter make the Model 2 the most durable budget EV. Comment Tesla Model 2 if you believe it would surpass most EVs on the market. 3. How will Model 2 reshape your TCO and daily routine? Tires and brakes, the hidden but very real 5-year savings. Choosing 17 to 18-inch wheels for Model 2 lowers TCO in a measurable way. Common 18-inch tires typically cost about $140 to $180 each, while 20-inch tires often run $220 to $240 each $300. At 12,000 miles per year and 30,000 to 40,000 miles per set, you will replace tires roughly twice in 5 years. Using $160 per 18-inch tire, 2 sets of 4 total about $1,280. Using $260 per 20-inch tire, the total is about $2,080. That is an 800 USD difference from wheel size alone. Regenerative braking is another win. In city driving, the friction brakes are used less, so pads can exceed 100,000 miles before replacement. During the first 5 years, you will mostly inspect, clean, and lubricate slider pins, avoiding the costly pad and rotor jobs common on gasoline cars. Charging strategy by location. Every 10% shift is worth hundreds. Assume 4 miles per kilowatt hour and add 10% charging losses. 12,000 miles per year needs about 3,300 kilowatt hours from the grid. If you charge at home on a night rate of 0.08 US dollars per kilowatt hour, energy costs about 264 US dollars per year. If you rely on DC fast charging at 0.35 US dollars per kilowatt hour, that jumps to about 1,155 US dollars. An 80% home and 20% DC fast mix is roughly 442 US dollars per year. A 50-50 split is about 709 US dollars. Shifting even 10% of your energy from fast chargers to home or workplace outlets saves tens to hundreds of dollars per year. For Model 2, the optimal habit is overnight home charging, opportunistic free or low-cost workplace charging if available, and reserving fast charging for road trips. Insurance, repairs, and the monthly budget. Small items that add up. Insurance for a small car commonly falls around 110 to 150 USD per month, depending on driving record and location. EV maintenance is simple. Plan for a cabin air filter at about 50 US dollars per year, brake fluid checks and condition-based replacement, and tire rotations every 6,000 to 7,500 miles to extend tire life. Model 2's integrated drive unit and 48-volt auxiliaries reduce large terminals, relays, and fuses, which lowers the chance of small electrical faults. Mobile service and remote diagnostics cut shop time further. So that's the roadmap, but the story is just getting started. Which part surprised you the most, and what do you think Tesla still hasn't revealed? Drop your thoughts below. I read every comment. And if you enjoy being ahead of the curve, join the autogearshift crew and help us hit 13,123 subscribers. Smash subscribe, ring the bell, and stay in the front row for the next breakthrough, not the recap after it happens.